Okay, good afternoon. In the previous session, you completed the different tasks: sensor types, sensor node, and then category of sensor, and then internet communication. In the internet communication, we discussed about the IP, TCP, UDP, and then TCP/IP protocol stack. That means we discussed the concept, and then coming to the IP. In the previous session, we discussed about the what is an IP, what is an IP address, and then what are the different types of IP address, and then the IP version 4 as well as the DNS. We discussed that concept. Now you are going to know about that means previously we discussed the IP version 4. Now we are going to know about the IP version 6. Here, what is a IP version 6? Internet Protocol version 6. That is also called as a IP version 6. Here, the IP version 6 is a successor of IP version 4. Why it is successor of IP version 4? The total range of the IP version 4 is a 4.3 billion. 4.3 billion addresses are there. Here, in the right side diagram shows that the 4 billion addresses are there. That means the IP version 4 having some drawbacks. Why? Because in the world population is a 700 more than 700 crores of people. That means you are using 4 billion networks in the sense. That means IP address in the sense. Why? Because every person having a more than one device in their hand. That's why it is a some drawbacks are there, and then that's why by eliminating that one, the IP introduced the IP version 6. Here this particular IP version 6, 128 bits each. That means range of this one is unlimited. Here 2 power 28 addresses are there. It's having the 2 power 28 addresses are there, and then the IP version 6 developed by the Internet Engineering Task Force to deal with the long and anticipated problem of the IP version 4 exasperation. Here, IP version 6 uses a 128-bit address. That means 2 power 28 addresses are there for the IP version 6. And then IP version 6 is a next generation of IP address. Your next generation. Now you are using for the each and every system IP version 4. The main difference between the IP version 4 and IP version 6 is the address size of the IP addresses. The IP version 6 provides a large address space. It contains a simple address compared to the IP version 4. That means in the diagram here, it's having a large addresses are there. Here, that means you are representing the addresses in this way. You're coming to the difference between a IP version 4 and IP version 6 is the address size of the IP addresses. Here, see here, the addresses. Here, the IP version 6 having the 2 power 128 addresses. IP version 4 having the 2 power 32 addresses are there. That means 4 bytes. Here, coming to the IP version 4 is a IP version 6 provides a large address space and it contains simple header compared to the IP version 4. And then IP version 6 use column decimal representation. For example, in the right side diagram shows some A dot, B dot, C dot, like the dots are there. Here divided into 8 groups. Here the first 3 groups are called as a prefixes, and then fourth group you represented as a subnet ID, and then remaining last 4 groups are called as a interface ID. That means in the IP version 6 divided into how many groups here? 8 groups. A dot, B dot, C dot, D dot, H dot. That means up to H. 8 groups are there. Each group represented 2 bytes. For example, I am taking the X is a one group. In particular group, here you have a 2 bytes here. That means how can you represent, for example, 200F, 200F. That means first 2 bytes. That means one information represented in a 1 byte. For example, that is a each and every group represented as a 2 bytes, 206, and then 001, and then 3239. Like that, you have a different groups are there. Here, coming to the address structure of a IP version 6. The address structure is a 128 128 bits are there. These 128 bits divided into 8 16 bits block. Here 16 bits block, one block consists of 16 bit. Each block is then converted into 4 digit, for example, 2020 is a 4-digit number. 4-digit hexadecimal number. That means you will use a decimal, hexadecimal number. What is the range of hexadecimal number? Can you tell me? The range of hexadecimal number 0 to F, 0 to 9. After that A, B, C, D, E, F. Up to F, you will use a different number separated by the colon. That means for each and every one, you are using a colon. And then, for example, 128 bits are there. The representation for the binary format, this one. Here, the each and every block consists of 16 bits. Here, the first one X, the second one X, third one X. That means it consists of 16 bits of block. Here, totally you have a 8 groups are there. Each and every group represented as a this 16-bit block, and then each block is converted into hexadecimal number separated by the colon. For example, 4525 is a one group, 0000 one group, 3238 one group. Like that, you are representing the this 6 IP version 4 number like this. Even after converting into hexadecimal format, IP version 6 addresses remains long. Here, this is a, that means it is a very long here. You will see here, for example, 192.168.1.1. It is a very difficult to remember. But if you see the IP version 6, very difficult to remember. Why? Because 8 groups. If it is a very difficult to remember 4 group in the sense, here the IP version 6 is a 8 group. That means it is a very difficult to remember. That's why you have a some rules are laid. That means some rules for shorten the addresses. That means in order to reducing the size of the address, you are using a different rules. What are the different rules here? The first rule here is a discard the leading zeros. For example, if you see the block 5, see here, the block 5 consists of 0063. The block 5 consists of 0063. That means it is having the leading zeros. It is having the leading zero. The leading zeros can be omitted. For example, that value represented as a like this. Here 4525. Here 0063. The 0063 represented as a only 63. If you have the leading zeros, you should remove the leading zero for the block or group. You should remove the leading zero for the group. That is a one rule. And then second important rule here is a if two of more blocks contain consecutive zeros. That means two or more blocks. For example, not a single block here. Two or more blocks contain consecutive zero. Omit them. That means all and replace with the double colon. Double colon appears like this. The double colon, not a single colon here. Here, see here. If you see this diagram here, the sixth and seventh group consists of all zeros. Continuous zeros are there. The continuous zeros in the sense you have to omit these continuous zero. In place of single colon, I am using the double colon. That means double colon. If you are writing double colon means there is a leading zeros. That means not a leading zeros. Two or more blocks consist of consecutive zeros. That's why you are going to omitting that zeros. That indicates this one. This is a one of the valid IP address of IP version 6. And then the consecutive blocks of zeros can be replaced by once by the double colon. So there are still blocks of zeros are there in the addresses. Here, if you see here, the address consists of second block. The second group consists of 0000. 4 zeros are there. These are all not consecutive block zeros. Here only one block consists of 0000. Here what is the thing here? Omit these 00 and replace with single zero. Here I am replacing with single zero. That indicates that what is the indication here? I am replacing the single zero. That means they're having the block of 4 zeros are there. The 4 zeros are replaced with single zero. That's why you are reducing the size of the IP version 6. In this way, you may reducing the size, even though it is a very difficult to remember. That's why you may take the DNS, a domain name system, converting the some names into IP addresses. For the that means previously discussed that concept domain name system. Here also you will use the domain name system. And then the next important one is a transition strategies. The IP version 6 provides a transition strategies that converts the IP version 4 into IP version 6. Here there is a IP version 4 is there, IP version 6. In order to converting the IP version 4 into IP version 6, this IP version 6 IP address provides a some of the strategies. Here what are the strategies? Here the strategies all follow. The strategies are dual stacking, and then tunneling, and then the network address translation. Dual stacking, tunneling, network address translation. Coming to the dual stacking. Here right side diagram indicates that IP version 6 application. Here there is a IP version 4 as well as the IP version 6 existed in a one system. Here it is a IP version 4 stacking, this one. Here the left side diagram shows the IP version 4 stacking. Like that you are stacking. Here, for example, Ethernet existed in a link layer. IP version 4 existed in a internet layer, and then TCP and UDP existed in a transport layer. Coming to the IP version 4 application. Here IP version 6 layer. Here in the link layer there is Ethernet is there, and then here you are using the IP version 4 as well as the IP version 6 in a single system, that is called here dual stacking. Here what is the dual stacking? The dual stacking allows us to have a both versions, IP version 4 and IP version 6 on the same device. Here you are giving the IP version 4 and IP version 6 in a same device. That's called here dual stacking. Here coming to the tunneling. Here what is the tunneling here? In this approach, all users have IP version 6 communicates with the IP version 4 network to reach the IP version 6. Here for reaching the IP version 6, we are using this one. And then network address translation. Here the translation allows the communication between the host and having the different versions of IP. Here different versions of IP is there. The host system always communication between a different version. That's called here address translation. The network address translation. Here coming to the IP version 6 packet header. A simple header is there. It consists of the portion with minimum functionality required for all packets here. Here may be followed by the optional extension to implement the special features. It is having the version, traffic classes, and then flow label, and then payload length, next header, and then scope limit, and then source and destination IP address. The next header is a one of the important one, and then it is having the fixed. This header occupies the first 40 octants. That is called here 320 bits of the IP version packets. It consists of source and destination addresses, the traffic classes, classification, it is an optional one, hop counter, this one also an optional one, and then type of the optional extension, the type of the optional extension, and payload is very important, which follows the header. These are all components of header. Here, how to interpret this one? If the packet consists of options, this field contains the option type and the next option. The next header is a one of the field. The next header field of the last option point to the upper layer protocol that is carried out in a protocol data. That is called carried out in a protocol data, and then it's consist of. That means these are all different information. Here, in this way, in this IP version 6 also, you will use a domain name system. In the previous section, you discussed about the domain name system. Here, what is a domain name system? Here, the host names are mapped to the IP addresses by triple A. That means A is a quad A. Resource records. Here, that means in order to converting the host names into IP addresses, for doing that one, for reverse resolution, IETF reserved the domain IP of version 6 .arpm, where the namespace is hierarchical divided by the one-digit hexa number representation of nibble unit. Here that is called here represented by the RFC 3596. Here you will that is a representation of IP version 6. Here coming to the different differences between IP version 4 and IP. Very important one. This one. IP version 4 is a 32-bit address. Here the address length. If you consider the address length, IP version bit is a 32-bit addresses. That means that consists of 2 power 32-bit addresses. Here IP version 6 is a 192-bit 128-bit address that consists of 2 power 128 addresses. If you comes to the fields, how can you represent the field? The field is represented by here is a dotted. Here in the IP version 6 represented by the colon, 2 dots, and then classes. Here the IP version 4 divided into 5 classes. A, B, C, D, E, and then IP version 6 does not contain classes of IP addresses, not having any classes. Why? Because 2 power 128-bit addresses are there. It is very difficult to divide in the classes. And then number of IP addresses here. Here, number of IP versions has a limited number of IP addresses. IP version 6 has a large number of IP addresses. The 2 power 32 addresses are there here. Here 2 power 128 addresses are there. Here virtual length subnet mask. Virtual length subnet mask support. Here the IP version 4 supports a VLSM. IP version 6 not supporting the VLSM. Address configuration. Here that means manual and dynamic host configuration protocol is used to configure the addresses. Here also supports the manual DHCP and auto configuration and re-numbering also supported by the IP version 6. And then that means address spaces are there. 4 billion address spaces are there. And then 340 and I don't know exactly that value. And then end-to-end connection integrity. Here, what is an end-to-end connection integrity? IP version 4 end-to-end connection integrity is unreachable. That means the addresses in this case 2 power 128 in a IP version 6. In case of IP version 6, end-to-end connection integrity is achievable. And then security features are there. What are the security features here? It depends upon a application. The address not depends upon a developed in keeping the security feature in mind. IP version 6 having the IPsec is developed for the security purposes. Here address representation here it is a decimal, it is a hexadecimal. IP version 4 is a decimal representation. IP version 6 is a hexadecimal. The fragmentation done by the router in a IP version 6. Here the fragmentation is done by the senders in a IP version 6. Here, packet flow identification. It does not provide any mechanism for the packet flow identification, but it uses a flow label field in the header for the packet flow identification. And then there is a checksum field in a IP version 4. In the IP version 6, not a checksum field. And then the transmission scheme. IP version 4 is a broadcasting. Here, IP version 6 is a multicasting. It provides a different network operation. And that means IP version 4 supports a unicasting, broadcasting, multicasting also. Encryption and authentication. It does not provide say encryption and authentication, but here it provides a encryption. The number of octants here is a 4 octants. Here the consist of 8 fields. That means 8 groups. Each group contain the 2 octants. This is a some of the references for the this one. Okay, ma. Thank you.